Now let's look at some examples of transformation problems involving translations. Some problems I will give you an equation and ask you to draw the graph, and some problems I'll give you a graph and ask you to write the equation. So let's look at the first type of problem where I would give you an equation and ask you to draw a graph. Now, at the end of this problem, I'll show you what I would exactly give you on the problem itself, but I'm going to kind of talk you through it the first time. One thing you have to be very familiar with is the parent functions. You need to know what all the graphs of the parent functions look like. So if I give you this equation, you could draw me a sketch of the graph from memory. Now, of course, you can always plot some points too and just recognize. So for example, if I put 1 in for x, I would get 1 for y. And if I put 0 in, or if I put -1 in for x, I would get -1 for y. And then I know that when I put 0 in for x, it's undefined, so x can't be 0. So there's an asymptote on the y-axis, and there's no way to make y equals 0, so there's also an asymptote on the x-axis. And the graph looks basically like this. So you need to know what that graph looks like, and then for purposes of the translation, you need to identify a couple of key points that will help you to do the translation. So here's what I recommend when you deal with asymptotes. Your asymptotes are going to act like key points because where the graph translates, the asymptotes also translate. So it's really important to think about this point here where the asymptotes cross is at 0, 0. There's also a point at 1, 1, and a point at -1, -1. So if I can translate those 3 points, I will know how to redraw the graph in its new location. Alright, so let's take a look at the transformation I want to do. I have here g of x is equal to f of x minus 1 minus 2. So you see it's x minus 1 inside the function and minus 2 outside the function. Now remember what f of x equals. So when I see f of x minus 1, that means I am substituting x minus 1 for the input of the function. So in other words, it's going to be 1 over x minus 1 in the denominator. So the denominator becomes x minus 1 instead of just x. Then the minus 2 is outside the function, so then I would have minus 2 over here. Now from translations, we learned that things outside the function, transformations outside the function affect y. They cause an up and down shift. So we see this -2 means that we're going to be going down 2. So this shifts us down 2. The x minus 1 inside the function, remember, has the opposite effect of what things do outside the function. So instead of shifting it to the left 2, subtracting 1 actually shifts the graph, or sorry, to left 1, it shifts it right 1. So the whole graph is going to shift to the right 1 and down 2. So I start with where my asymptotes are, 0, 0. I take that point 0, 0, shift it to the right 1 and down 2, and now I have this point right here. And this is now where the asymptotes are going to cross. Then I take my point 1, 1 and shift it right 1 and down 2, and now it's right here. And then I take my other point, -1, -1, and shift it right 1 and down 2, and I have a point right here. And now I can draw the translated graph. So identify the parent function, identify a few key points on the parent function, and that should always include asymptotes if you have asymptotes, and then use the translations to shift those key points and then redraw the graph. And I'm not looking for a perfect graph, I'm just looking for a sketch of the graph with a few key points clearly marked. Okay, let's take a look now at when I give you a graph and ask you to write the equation. Alright, so first of all, you have to identify what parent function this represents. So hopefully you recognize the parent function f of x equals 1 over x squared, which is just the graph that looks like this with the x and y axis as asymptotes, and it goes through the key points 1, 1, and negative 1, 1, and then of course it has the asymptotes meet at the point 0, 0. Now the transformation that's been done, let's draw in where the asymptotes would be here. Notice where the asymptotes cross now is the point 3, 0 instead of the point 0, 0. So the transformation has shifted us 3 to the right. Shift right 3. So how would I write that? I would write that as that g of x is equal to f of x minus 3, because to shift it to the right 3, I have to subtract 3 inside the function. Now, how would I write the equation? I would replace the x minus 3, or replace x in the original parent function with x minus 3. And since it's squared, it's really important that I put that in parentheses. So the equation, g of x now, the translated function, would be 1 over the quantity x minus 3 squared. So think about when we talk about inside the function versus outside the function. The parent function squares x and then does 1 divided by that squared number. If I were making a change to y outside the function, I would go ahead and do the entire function and then add or subtract something outside of that. But if it's affecting the input, then I have to change x before I do anything. So I change x, subtract 3 from x, then square it, then do 1 divided by that number. So changing x happens first. It happens inside the function. It happens to the input. Okay, the second one. This is the graph of an increasing exponential function. The parent function here is f of x equals 2 to the x. There's an asymptote here. The graph would look like this. Have an asymptote on the x-axis, and then go up like this. And remember, if x is 0, y is 1. So it has a key point here at 0, 1. And that's kind of the important point that we're going to look at, the asymptote and the important point. So notice here, now the asymptote is at 2, and the key point is at 0, 3 instead of at 0, 1. So notice everything has shifted up 2. So this is a change to the y value. It is a change outside the function. So the transformation would look like this. G of x is equal to the entire function f of x plus 2 outside the function. Or, if I write the equation then using the parent function, 2 to the x plus 2. So that's what the transformation would look like. The equation of that transformation would look like. This next one is a square root function. The parent function is f of x equals the square root of x. You know from the notes at the top of the page what the square root of x function looks like. It has a point at 0, 0, and it has a point at 1, 1, and it has a point at 4, 2. So where did those points go? So let's think about where the point at 0, 0 went. If it was at 0, 0, it shifted to the right, or to the left 3 and down 2. So we have left 3 and down 2. So we are making one change to the x coordinate, shifting to left 3, and one change to the entire function, which is the down 2. So if I wrote the transformation, g of x equals f of x plus 3, so a change of plus 3 inside the function, and then minus 2 outside the function. So now, if I write the actual equation, g of x is equal to the square root of x plus 3, and then outside the square root, minus 2. So those are some examples of how you do translations with parent functions. Make sure that you know your parent functions very well in order to do these.